So I formally welcome you all to this year's Founders Day lecture, and also hearty welcome to Dr. Shailesh Naik, Director NIAS, and thank you for accepting our invitation and coming over here to give the lecture titled Climate Change Implications and Way Forward, very current topic and extremely important topic as well. So let me introduce Dr. Shailesh Naik. He is a well-known figure. Most of you would have come across his profile some way or the other or in some connections. But let me have a formal announcement of his achievements. Dr. Shailesh Nayak currently is the director of National Institute of Advanced Studies, Bangalore, editor-in-chief, Journal of the Indian Society of Remote Sensing and Live Trustee of India International Center, New Delhi. He was the chair, Earth System Science Organization, ESO, and secretary to the Government of India for Ministry of Earth Sciences between August 2008 and 2015, a former chancellor of the Thirty School of Advanced Studies, Delhi. He provided leadership for the programs related to science of climate change, weather services, polar science, geoscience, ocean science and modeling, ocean survey, resources, and technology. His current research interests include building strategy for the blue economy, sustainable development, and science diplomacy. Dr. Nayak obtained PhD degree in geology from the MS University of Baroda in 1980. He joined the Space Application Center, Indian Space Research Organization, in 1978 as a scientist and subsequently elevated as director of Marine and Water Resources. He was mainly responsible for conceptualizing, formulating, and executing many national level projects related to application of satellite data on ocean color, integrated coastal zone management, snow and glacier studies, and water resources. The generation of detailed information on the Indian coast has influenced the development of policy for zoning of coastal zone for regulating coastal activities and was closely involved in restructuring coastal regulation zone notification issued by the Ministry of Environment and Forest, Government of India. Dr. Nayak was appointed as a director, Indian National Center for Ocean Information Sciences in Kois, Hyderabad, an autonomous institution under ESO in May 2006. At ESO in Kois, he set up a state-of-the-art early warning system for tsunami and storm surges in Indian Ocean. He was responsible for the conceptualization and development of marine GIS. He has made outstanding contributions in improving advisory services related to potential fishing zones, ocean state forecast, and Indian agro project. He is a member of the governing board of the Indian Space Promotion and Authorization Center in Space, Foundation for Ecological Security, Anand, and National Center for Sustainable Coastal Zone Management, Chennai. Dr. Naik, Chair, Jury for the National Blue Flag Committee, Research Advisory Committee of ESO National Antarctic and Ocean Research Center, Goa, ESO National Center for Coastal Research, Chennai, Wadia Institute of Himalayan Geology, Dehradun. Dr. Naik is a fellow of the Indian National Science Academy, New Delhi, Indian Academy of Sciences, Bangalore, the National Academy of Sciences, India, Allahabad, the International Society of Photogrammetry and Remote Sensing, ISPRS, and academician of the International Academy of Astronautics, Paris. He has been awarded honorary degree of Doctor of Science by the Andhra University in 2011, by the Assam University in 2013, and by the MIT University in 2015. Dr. Nayak is recipient of IGU Harinarain Lifetime Achievement Award in Geosciences 2013, the ISCA Vikram Sarabhai Memorial Award 2012, the Bhaskara Award for 2009 by the Indian Society of Remote Sensing, Dehradun. Considering the impact of his research on the society, the Government of India has conferred on him the civilian honor Padma Shri in the field of science and engineering in 2024. Dr. Nayak is the president, Indian Geophysical Union Hyderabad and Indian Mangrove Society. He has published about 190 papers in international and national journals and has delivered about 200 invited talks in national and international fora. So it's an amazing set of achievements. I think there's a lot more, but I could only put these all together. So we heartily welcome Dr. Nayak to deliver this lecture, please.
Thank you very much for inviting me. I'm extremely grateful to Dr. Napuni to giving me this opportunity to talk about the climate change impacts. Before I start, I would like to pay my respect to Dr. Bapu, who, of course, as you know, that he was a pioneer in this country. But one of the very important thing which he was also a member of the first INSCO Spark Committee, which was set up under Dr. Vikram Sarabhai. And he was also equally responsible for the space research in this country. So his contribution, not only the astrophysics, but as a part of the space research was very important. And probably at that time also it was realized that satellite would be another source of understanding the astrophysics and aeronautics. So he was a real visionary, and I think I'm really grateful to director for inviting me in his memory, and I'm sure that his legacy we will be able to take forward. Now, as we know that the climate change, of course, everybody knows that there is something happening. But the main important thing before we try to understand, we must understand that the Earth is a single unit and there are different components, ocean, atmosphere, geosphere, biosphere, and the cryosphere. And there is a continuous exchange of mass and energy between these components from a local to global scale as well as different time level. So this is the basic, and in this, the human interference, especially last 150 years, affected all these processes. And in turn, also, this process is also got affected by the anthropogenic activity. So this is the main thing which is we try to understand and model to find out that what is likely to happen. Now, this Earth system science, as we call now, it's a much later. In 90s, it started gaining ground because after the satellites were orbiting around Earth, we realized that there is a lot of interconnection between the different regions, different processes, and that led to a science which we now call as the Earth system science, which is, of course, mainly geoscience, but also the ecosystem science, space science, and since it deals with the societal issues, it also with the social science, economics, and cognition. So now, as we see the Earth system science, when we call, is all these aspects are one way or other way are handled into this. So this has become now a fundamental science to understand the earth in which we live. So whatever is happening within the earth, unless we have an understanding about the earth system processes, we won't be able to sustain the whole thing on this. So that is the basic thing which with earth system science works. Now, if you see this last 11,000 years or the period which we call as the Holocene, the climate was very stable, about 15 degrees centigrade. And that is the time when all civilizations grew. This, we now know that there is a direct relationship between the carbon dioxide, sea level rise, and temperature that we know from the records of last 400,000 years from the ice core. So, which has been reconstructed, and we know that last 10,000 years only was the very stable period. Before that, there were a lot of glacial, interglacial periods. Recently, there is another major thing which was found that about 5,000 years ago, there was a major drought in Eurasia, and this evidence came from a cave in Meghalaya, and that is now being recognized as a Meghalayan age. And that is during this drought, many civilizations were lost, and one of them was the Harappa. So the climate has directly impacted on those times how the civilization grew. Coming much nearer, between 10th and 14th centuries, we had a warming period, and then 15 to 18 we call as a little ice age, when the earth was much cooler. Now, during 10 to 14 centuries, if you see in India, there were a lot of invasions from the northwest. And that is the time when the many, mainly from the Central Asia, the people came and occupied this territory. And during this time, the 10th century, the Mayan civilization was also lost. Between 15th to 18th century, especially Ice Age, which was more in the Europe, that is the time also the European also started going out for various things. And they colonized the almost entire world during that time. So basically, I'm trying to say that the climate and the human civilization has a very close relationship. And that is why we need to understand what exactly happened in the past. And that is why, and then based on that, we can project that what is likely to happen. So let's see that what are the projected changes which is in the climate. India has its own model, Earth System Science model, developed by Indian Institute of Tropical Meteorology, and we now participate in all IPCC meetings and with our own model and the outputs, which are taken into account when the entire IPCC reports are made. So what we found is that the temperature can be as high as 2.4 to 4.4, depending upon what kind of emission scenarios we develop. The major impact is likely to be on a monsoon, where we know that the light and moderate events are likely to decrease, and the extreme and extremely heavy events are going to increase. And we all have been experiencing this, not only in India, but everywhere. Recently in Uttarakhand also, the very heavy rainfall can create a havoc and the large amount of damage to property, and many lives were lost. Now, in the southern India, the rainfall is likely to increase much more than the overall Indian region. The other important thing is that the temperature is also changing. That means the cold days, cold nights are decreasing, and hot nights and hot days are increasing. So this would have also impact when you have both these things, that you have the increase in the rainfall also, but the extremes are increasing. So what is happening is that you have a floods also, but you will have a droughts also. I mean, we have been seeing in country today that one area may be having floods, but the other area may have a drought. So we also need that the frequency of the drought is also very important. And when you have this kind of extreme events, both the flood and drought are likely to damage the lives of affect the lives of the people. And this, we need to have much more local level understanding. See, currently what happens is the most of this model give more regional or a global picture, but we need to, if we have to take any action, we need much more higher resolution models to be developed. Now, in Northwest India, we are finding there are many changes happening. The one thing which is happening is that we are seeing that the season, the rainfall, shifting from east to west. There were normally in the 50 to 60 days, 70 days in northwest and 150 to 160 days in northeast. Now this in northwest, the number of rainy days are increasing, and in northeast it is decreasing. And the evidence of this, that we have now a lot of floods in Gujarat, Rajasthan, which was normally not seen even in the Kutch. So the rainfall has been shifting more towards the west, and this, the Indus Basin, which is in the northwest, is very important because this, the shifting of monsoon is not affecting much the Indus Basin. Indus Basin is mostly on the snow cover belt. So that is another area, and you all aware that about the Indus Treaty. So there are issues that how the snow cover is likely to change. So in the northwest, there are many changes are likely to happen or already happening, and this we need to take into account for the future planning. So this is the different models that we tried, and all show that the rainfall is the slow, light rain is going to decrease, and the heavy is likely to increase. Now, this changes, especially in the monsoon. We need to understand what will affect the water resources, agriculture, fisheries, ecosystem, how these changes are likely to affect. So that is the one. Now, to understand that, as I told you earlier, that we need a high resolution models, which is tries to address a specific phenomenon in a specific region. Now, those models are not currently available. So that is the one which is very important for us, that you develop a models which are provide information at the region and the local level, because then only we would be able to initiate necessary action as well as plan the necessary adaptation measures. The second thing which is required is how those heat and cold days and the extreme rainfalls are going to affect the different kinds of diseases, especially malaria, dengue, meningitis, cholera. And we know that in the Bangalore, fortunately not much, but in Delhi, the dengue and all is becoming very serious issue, and essentially because of the extreme heavy rainfalls. The other is, at the same time, we also need a drought information system. Now, we do have understanding about this, but the information which is essentially depends on the meteorology and hydrology, we also need to integrate the social science part of it. Because the changes which are happening, like if it is in Rajasthan, the drought, people don't feel that problem because they are adapted to availability of a low water, but or in Maharashtra. But if the drought occurs in areas like Northeast where you have a large amount of water, then there would be issues. So we need to understand drought with respect to how the society is seeing the drought. Now, there is a major impact would be on the water cycle. Our per capita availability of water is decreasing year by year because of the increase in the population. And as the light and moderate events are decreasing, and the heavy events are heavy and extreme heavy events are increasing, the percolation to the ground would be very low. And most of the water is likely to flow as a runoff. Now, this would have a major impact on the what we call as a shallow groundwater table. The water which is available in the first few meters of the land. Now, this actually interacts quite significantly with the atmosphere. And also, this is the water which is useful for the crops. And also, the shallow groundwater provides water to the rivers. Actually, many times you see that the river is dry. That is essentially because surrounding groundwater level is also much lower. Wherever the groundwater level is increases, you will see that water in the river also will increase. So maintaining the shallow groundwater table is very critical for our rivers to flow, and that will also affect the local ecosystem, crop, and the drinking water requirement. So that is going to be affected much more. So what we need to do is that what the way we do census of people, that how many people are in which places, we need to find out what is the requirement of a particular green, that how much water is available and what is likely requirement, both for the people and the ecosystem. And accordingly, we need to plan that how we can take water from one region to the other. So this kind of a water census is very much required. The second is the floods and droughts has been, I was telling you earlier. Now, there are certain areas have been found where the problem is likely to be much more serious. So two basins, one the Sabarmati and Luni, which are almost adjacent to each other. These are the two which is likely to have a serious issue uh, in the northwest India. Both they will have a large amount of droughts as well as the floods. The second is very important is that the northwest Himalaya, we have been seeing now increased events of the floods. There are several floods. We know that Uttarakhand and then Pakistan, both are having a large amount of floods, including one in the Srinagar, Kashmir as well. Now, these floods, the whatever the forecast system which we have has been developed essentially for the plain region, and most of these floods were not forecasted adequately because the time is also very short, and we need a very good system to provide advance information about such floods. So that is what is very much required. And second is that if you want to build such system, the kind of observations required are also much higher. If you have seen during the recent flood, they had a rainfall data of only at Hershey, not further up. So exactly, we still not know what exactly happened. So we need to improve the observations and develop a system, especially for the Himalayan region, mountainous region, where the floods are becoming very routinely happening. Slowing glaciers, we know that most of the glaciers are decreasing, they're retreating the 1 to 60 meter. There is a quite different rates at different level. That depends on the type of glaciers, its topography, the way it faces whether it faces sun or not. So there are several issues, but the overall in region is about 16% loss. And this estimate is quite correct because in Chinese Himalayas also, which is separately done, there also the uh, loss is around 17%. So we are losing 16 to 17% of the in about 10 years or so. Now, the Western Himalayas are retreating much slowly than the Central and Eastern. The Western is mainly based on the snow. There is not much of monsoon, but the Central and Eastern is monsoon dependent, and there the retreat is much faster because there is not much snowfall. It's mostly on the monsoon. Now, what the model says that we may lose about 27% of if there is a high emission by 2100. So some of the people earlier said that by 35 there won't be any glaciers. Of course, our model says that it is not likely to so, but definitely glaciers are reducing. Now, to understand the retreat of glaciers, what we need is a mass balance study, is how much the accumulation and the ablation is happening. This is done only for very few glaciers. So we don't have complete understanding about this. The GRACE data said about 4 billion tons of ice is reduced every year. Now, such a large amount of mass, if it is being transferred from land ultimately to the sea, what likely changes are going to happen? And that is not known. And normally, when you take out some weight, the pressure is released and the land is likely to come up. And that is why we need a better geodetic networks to understand whether there are any changes happening. And we know that this kind of changes can bring certain tectonic adjustment because of this. And you may get certain fractures and all developed. Actually, the last 2 years back, which has happened in the floods which came in this place, Ganga and all, is essentially when the entire glacier mass came down. And the fracture which is developed, which is not normally develops with the plate movement. So we need to understand that changes which are happening of the mass, of the glacial mass changing, could be a reason for certain tectonic readjustment in the Himalaya. The other is the ice is the second thing. The first thing is the snow cover, and over a period of time, the snow translates into ice. Now, what we know is that in Bhutan it has reduced about 3%, and in Arunachal. So, with the other areas, we do not have any information whether how much snow cover or snowfall is reducing. If snowfall is reducing, ultimately we may lose the glaciers. Now, so that information is very much essential. Now, but this information is quite differently in different regions. In the western region, the most of the snow cover accumulation happens in February, March, and November, December. In the central region, the snowfall definitely occurs in the winter, and the monsoon months are different. So both completely two different seasons. But in the northeast, you have the monsoon and the snow same season, the northeast, because that will be November to December. So this has a major impact on how the snow cover is going to change. Now, if the rainfall is increasing, the snowfall is going to be less, especially in the central and eastern, and that is why those glaciers are retreating much faster compared to the west. Now, Indus is the one which is very much concerned because our major food, 25% of our food, and Pakistan's almost 90% of the food is in Indus Basin. So any change in the snow cover can have a large impact on the availability of water in this region. And that, what is now computed is that the snow, this one estimate of 15 billion cubic meters in Indus, Ganges, and Brahmaputra. And there is a possibility of a reduction about 8, 17, and 19%. So which is quite substantial. If this kind of water reduction happens over a period of time, then the availability of water in North India and the Northwest India would be very, very high. Now, as we know that the changes in the monsoon pattern, up to certain extent, the agriculture can take care of, even if the increase in rainfall may benefit. But the issue is increase in the carbon dioxide also affects plants, and it affects different plants. So the increase in the carbon dioxide, like paddy and wheat, will be affected, the yield will go down. But the other crops like sugarcane, millet, sorghum, soybean will have a higher production, higher yield. So because of the changes in their leaf structure. So that is why now you must be seeing that the government is saying that more on the millet than on the wheat, because wheat production is going to reduce, but the millet and all, they will basically thrive. The second is also the hot days is another issue because the grain will mature faster. Like in wheat, which is normally harvested in April, and now the temperature increases in March itself. So grain becomes matured in March and the second, third week of March. And so grain will become smaller. So the yield is decreasing with the increase in the temperature. In the Thar desert, as I told you that because of the two things, one, the Indira Gandhi Canal, because also increase the moisture in the atmosphere and the shifting monsoon, the more crops, more greenery is now seen in the Thar desert. You can see this in last 20 years of data. In this particular region, which was green, you can see here is more yellowish now. That means the productivity in that region has increased, especially this is agriculture, this during the monsoon. So there are changes occurring in many other areas, but the most dramatic change which we are seeing in this region. You can see it is very yellow, quite yellow, and green is much less now. So this, in the Rajasthan, it is benefiting that the changes in the monsoon has definitely benefited the production of grains. Now, when such changes are coming, we also have a very good advisory which provides the farmers about the rainfall, temperature, wind, cloudy days, and humidity at the different times. And this kind of advisories are given to farmers. And this is now, earlier, of course, it was a district level, but now it is at the panchayat level. And the updates are also given at 36 hours, 36 to 5 days, 3 hours, and 6 hours for. So very fast changing. If you download the IMD Monsoon app, you would know immediately that how fast they are updating all this information. So this is actually now a mainstay for all farmers for their farm operations, either sowing, plowing, application of fertilizer or application of pesticides, or changing what kind of a crop variety should be chosen, etc. And this is now, they have enabled several apps through which they can get. And all this turns into a benefit about 10,000 crores. And this was done by National Council for Applied Economic Research. So third party completely. So that is why in the beginning I said that the information or the science which we have has to be used for the societal benefit, and it has to have an economic benefit. So that is the most of these services, we try to find out what are the economic benefits. And you can see this, the impact of such advisories. This is in Karnataka. You can see that those who the benefit, and these are all small farmers, not a large farmers, 2 acres, 2 hectares, 12 different crops, they have different advantages. So when you use the advantages of using such advisories is that you unnecessarily don't get into operation which may not be beneficial. Like if it is going to rain, then you apply fertilizer but not the pesticides. And if it is not going to rain, then you apply pesticide, not the fertilizer. So this is helping quite a bit to the farmers. And this service is, of course, available throughout India. But this is the case study in Karnataka. We are doing this for the different regions, for Andhra, Maharashtra, and everywhere. And everywhere, more or less, the same kind of information is now available. The other major change which is happening is in the sea level. And of course, the average sea level is around 3 millimeter or so. But how that average changes in the sea level can translate in on the coast, and what likely changes you can see. You can see this in how it has changed in last 50 years or so. And this is essentially because of the changes in the sea level and the amount of sediment which is receiving. So there are such large changes are seen on the Indian coast all along. And so every year, this is being now done to find out where the changes are occurring. Now, why it is very important is because this, we have a large amount of people who stay on the coastal regions. And in many areas in the Orissa coast, the villages have to be shifted because the entire thing has been washed off. Also, it will have a changes in the groundwater. It will increase the salt and ingress into the coastal regions, and which will again affect the agriculture and all. So this sea level rise, we need to understand in much more better way that if the average is rising, say 3.3 or whatever, how much changes you expect on the coast. Because each coast, geometry wise, it would have a different levels. Like if you go to Sundarbans, the changes which see is as high as 11 millimeter. But if you go to Mangalore, it would be about 2 millimeters. So different levels will be changing, and that we need to model to find out what is likely to happen in as the sea level increases in coming years. The second is some of the important ecosystem like mangroves. Now they are very critical for the fishery and also protecting the coast from the erosion, either sea level rise or cyclones. Now, what we found is that the different kinds of species also has a different to cyclone. Now, why cyclone is because frequency of cyclone is also increasing. And on the east coast, the mangroves provide a one first level of a defense to all such storms. Now, this we found that the rhizophora and Abyssinia, these are the two main. The Abyssinia are affected much more than the rhizophora during the cyclone because of their root system. So, when you want to protect the coast, what kind of a species should be planted is also becoming very clear now. We also see that there are changes happening. Like when the sea level is rising, that means the marine influence is increasing. And the mangroves are in the intermediate between the freshwater system and the marine system. So if the freshwater supply is less, and then marine influence will increase, or the sea level rises, then the marine influence increases, the freshwater influence decreases. And that changes the species, as we have seen in the Sundarbans now. The Sundarban now, it comes from a Sundari trees, that is heritaria, which is a freshwater loving mangroves, now reducing and taken over by the Avicennia, which is the marine uh, mangrove species. So there are already many changes are happening, and those changes are also leading to different aspects, like when the soil gets salt affected, the agriculture shifts, and we are now finding that the people are shifting from a paddy to aquaculture because aquaculture can grow in the salt environment, but the paddy cannot. So there are a lot of changes happening in this region. The second major change is about the increasing carbon dioxide. Now, this is very important. I just mentioned earlier also. The when the carbon dioxide increases, the photosynthesis activity increases, and especially in the mangroves, this is further increases. They become thicker and absorb more carbon dioxide than any other plant. So it is very useful for sequestering carbon dioxide in this. So actually in India, the mangroves are increasing. So we are more sequestering the carbon dioxide than anybody else. The second important thing is as they sequester more carbon, ultimately the carbon burial rates into the soil organic carbon also increases, and the carbon dioxide is permanently transferred from atmosphere to the land. So these are very important for us to understand. So there is a continuous monitoring system for mangroves is being now set up in the country. And we also need to find out how much storage is increasing over a period of time. So the mangroves are monitored every 2 years by the Forest Survey of India, and you can see that how the things have been changing. Uh, you can see that most industrialized area, Gujarat and Maharashtra, they have increased. And that is essentially because of the awareness of the people and large amount of plantations are being done. And it is decreased in Andhra, and West Bengal is more or less same. Andaman, it has decreased mainly after the tsunami. So there are some people think that the industry, whenever industrial development will lead to ecosystem degradation, but it's not necessary. It is always, you can see that it depends on the people, how conscious they are about the environment in which they live. Other major change, and those who are from Kerala would know that the sardine and mackerel are two important fish in Kerala and Karnataka coast. Now, what we have been seeing is that the availability of both sardine and mackerel is decreasing on the Kerala coast and Karnataka coast, but increasing on Goa and Maharashtra, as well as there was no sardine mackerel on East Coast, but now you get quite substantial sardine and mackerel on the East Coast. Now, this is happening because of the increase in the temperature, the warming of the sea, and the fish is shifting northwards and much deeper waters so that their environment is more conducive. It is not that there are many reports that it is overfishing and all that. Overfishing and all may happen in one or two areas, but the large scale change which you see after 1985 is consistently is clearly says that it is the warming of the sea which is affecting the shift in the regime of oil sardine and mackerel. And this is affecting more to the fish which are pelagic from the surface because the warming becomes much higher. So there are many such changes, but many fishes now likely to move further northwards, which are the cooler waters and the hot waters which are in this region. The coral reef is another major area which many of you might be reading in the newspaper. It's likely to be affected much more because of the higher temperature. Now, what we found is that this is very important ecosystem from economic point of view. A study done in Indonesia, which shows that 1 hectare of coral reef is equivalent to about 3 billion US dollars. So income generating from the corals is very high. Tourism is one, but the fishery, ornamental stones, and many other things. But what we found is that the bleaching is not uniform, that the soft corals, which are much more first succumbs to increase in temperature, but also develops some kind of adaptation to the higher temperature. And we have seen that the areas which were bleached are now being seen as a new recruits in Gulf of Cambodge. That means they have developed or they have adapted to the higher temperature. So in Gulf of Mannar, we are seeing the new corals coming up, and that means that they are adapting to the higher temperature. So this is very important because the corals have a symbiotic relationship with the algae. Those who have seen coral, which would be of a different colors, the color is because of the algae. So the coral lives on that algae. So if algae dies, the coral will die. So many people are thinking that actually it is algae which is adapting to the higher temperature, and that is why the corals are able to survive. Because we see even in Persian Gulf, where temperature is 36 degrees, you get a coral reefs. So this is one area, but the danger is much more from the ocean acidification. If the pH level is going up, then the calcium carbonate skeletal can dissolve. And that is much more worrisome than the higher temperature. So the temperature maybe the corals will adjust, but if the pH increases, I think that is where the more serious issue will come. And that is why now what we need as a different IPCC scenarios, what is likely to be the pH? We know that what is likely to be as temperature, but the models to give a prediction about pH is not available. So that is what we need to understand that what likely to happen to the corals. Now, as we know that the hazards and are increasing, there are many hazards, but we will just talk about two. So first thing which we tried to do is that entire Indian coast, what is the vulnerability to different hazards? The cyclone or inundation, high waves, tsunami and all. And based on that, very detailed maps are produced, which shows that whether this red means it is a hazardous zone and the green is, we have just made it very simple map. There is a lot of categories within this. So this kind of information is now available for the entire Indian coast. So if you have to invest in any region, you know where to invest, or if you invest in the hazardous area, your expenses will be much higher to do certain engineering work to protect your property from such hazards. But what we advise is use the areas which are green for the further development. Don't use areas which are red. Now, the second thing is of course, you know the cyclone 25 years back when it happened in Orissa, 10,000 people died. And today you see that there is hardly any death. During large cyclone in Gujarat, there is not a single death has been reported. Now, this has happened because of 2-3 things. One, the forecast of the cyclone track and the time and the landfall point now very accurately are provided. But that is not enough. This information now is taken by the administrator at the national, state, and the local levels very seriously, and appropriate response mechanism has been set up. So whenever such thing happen, immediately they are able to respond. And third is the people who are going to be affected also trust this forecast and they are ready to move. Because like in Orissa, they moved almost 2 million people for 3 days. It's not a joke. Unless you are prepared to move them and they have to be provide food, water, sanitation, shelter, everything. So the governments are now prepared to address this, and that is why this has drastically reduced. And this is a good because now the frequency of cyclone is increasing. We were not having much cyclone on the Arabian Sea, but now we see regularly cyclones in the Arabian Sea, apart from what we see on the Bay of Bengal. Now, last part is that the climate we need to mitigate. And what are the policies and how the different countries, because mitigation, if it is done by a single country, it doesn't affect because it has to be done by everybody. And this is the important thing we have to realize that all countries which have developed economically have used large amount of energy. So the development and energy use is definitely going to add more and more carbon dioxide to the atmosphere. So what the basic thing what we need is one of the things that we should reduce the energy use. Reduce your fossil fuels, increase your efficiency of the energy, use of renewable, and sequestrate carbon dioxide through carbon sinks. So these are the three major strategy for the mitigation. Now, what we have been doing, of course, we have a major focus on the renewable energy. We have now achieved almost 50-50 the installed capacity. I'll come back that to later. The second thing is the problem with the renewable is it is not stable and it is only available during certain period. It is not continuously available around the clock. So the one solution which was suggested is to have battery storage system. Now, the one estimate that even if you put 25% of the renewable energy as a storage, you will need huge amount of money, about 14 lakhs crore to 17 lakh crore. So it's a huge money, and also it needs a critical minerals, the lithium, cobalt, nickel, rare earths, which is not available. So the storage is also going to be issue. The other is the pump storage. That means during the daytime, you take the water to higher reaches, and during evening and night, you allow that water to come to generate electricity. But there are environmental issues. Even in Karnataka, this pump storage was not agreed upon because of the environmental issue, because you will have to construct a barrage, which may be in a forest land or such. So the renewables, is not going to resolve the problem. I mean, it will definitely provide some amount of energy, but it is not going to. Now, the second is what we have suggested is that you reduce close down some of the thermal power plants, which are inefficient and 25 years old, which have emitted large amount of carbon dioxide and suspended particles. You close it down and replace them with a high efficiency, low emission plants. So that is the another way that you close the older technology, find the new technology, and this would be much better. But this is the one. Second is you try to use the coal gasification. This is another thing which is likely to happen. But the most important thing which is likely to be done now, and now government is agreed to, that we need to set up small and modular nuclear plants where like industry, where the stable power is required. So there you can have this kind of a system and which will provide stable power. It doesn't release any carbon dioxide. There are some people who think that what is the about safety, but the issue is why we are worried about safety is because the radiation data from our existing nuclear plant is not made transparent, open. Like other things are open, like pollution data. You know what are even in Delhi and all, they know it is unhealthy to stay in Delhi. People continue to stay. But if you do not have the information about how much radiation is happening, then people will feel that there is something wrong. And actually, our radiation levels are very low. So we have been requesting to Atomic Energy that you please release so that people develop confidence that it is not going to be unsafe environment. And this is now, uh, you must have seen that last budget, the nuclear mission has been announced, 20,000 crores, essentially to develop the small and modular reactors. And I think the five will be developed before 2030. And then it is planned that the large by 2047, they want to generate about 10% of our electricity requirement from nuclear power, which is currently about 2%. So the huge increase is likely to happen. And this is the only way India can achieve net zero by 2070. There is no other way by which you can achieve the net zero. So we will have to depend on the nuclear energy more and more. Now, if you see this, the climate, there's a lot of hue and cry about India. I mean, you must be reading. Now you can see that coal consumption per person, gigajoules per person, India is lowest. USA is almost more than 2.5 times. Australia is 5 times. So everyone is much higher. Even Europe, which sounds so much, its use is much more coal than us. Oil also, if you see, our is very low. Gas is very low. Coal power plants, USA and ours are same. They also have same thermal power plants. Europe has slightly less. China, of course, is more. So everybody, and the gas also, our is less. So all of them are using fossil fuel much more than India per capita. But they shout on us that we are doing the much more damage. While actually it is all these developed countries have much more to do. Even the other things like mitigation technology. This is the normal leaf area in our country in 2000. Of course, India's leaf area is the least because our forest cover is low. Brazil is the maximum. But the changes in the leaf area, that means how much dew plantation has been done, India is coming second. Same thing, the vegetated land area, we are much lower. But proportion which is green is India is on the top. And browning, that means the vegetation which is dying, we are nowhere in the first 10. And this data is not from Indian author, this is from US only. So India has been doing pretty well to mitigate the whatever we have been doing. And this will I'll show you in another example also. Now, as per the Paris Agreement, we were to reduce 45% of emission intensity by 2030. We have already reduced 36%. So we are right on the target that we will achieve the 45%. 50% share of non-fossil fuel generation. Now, what we are generating through renewable is 242, and fossil fuel is also more or less same. So we have already achieved 50% of installed capacity of renewable and the fossil fuel based. And same thing, creation of 2.25 to 3 billion tons of additional carbon sink We have already done 2.29. So we are right on the target. Actually, some of the target we have met just 5 years before. And this also will happen in a couple of years. And this will also happen before 2030. And we have been accounting only 3% of the historical carbon dioxide emission. So our share in the current situation is much less. But the kind of narrative which is that we are responsible. So that is why I thought this information would be very useful. And the performance, this is again done by German NGO, and India is consistently coming on 7th year after year, much ahead of US or China or Germany or Saudi Arabia, of course, there. So we, of course, they have not given first three, but 4, 5, 6, 7. So we are in top 5 to as far as the performance of mitigations is concerned. Now, this is the last one, that what we are trying to do is that we have this Earth system knowledge which we have, but this we have to integrate with the social system. That means appropriate governance and the policy. And we need to create infrastructure to take advantage of this information. And the most important, the behavior of people is very critical. Because this will depend both the kind of governance system which we'll have and the information which is being used to have that behavior. I'll give you a very small example. In India, in most houses, I have seen that you switch off your light when you come out of the room. And if you don't do, your mother or somebody will tell you to do that. In US, they continuously keep everything on. And the argument they say is that we can afford it. It's not a question of affording, because putting additional carbon dioxide into, you are affecting others as well. So India, in the many of our normal lifestyle, is such which is quite conducive for mitigation action. Even some of the waste material which we like to circulate, all such things, food waste. There are so many things. If you see from morning to evening, Indian behavior or the lifestyle is much more conducive to environment than the what you see in the West. So with this, thank you very much for this. Question?
Thank you, Dr. Nayak, for a very thought-provoking lecture. So if there are any questions. Yes.
I think it is very important to point out that India has been doing very well in climate change. But I think it's also counterproductive in a way, because we will also be one of the people who will suffer the most when climate change will occur, as it will. You know, where are the people in Bangladesh going to go? Where are the people in Mumbai going to go? Temperatures in Delhi are already unbearable. It's going to lead to human death. And so that's one part of it. And the second part of it is, I don't think we've done enough innovation in new climate, in new initiatives. So I just wanted to.
Yeah, I fully agree that we should continue to do whatever we can do to mitigate the climate. And as you can see that the agreement, Paris Agreement, we have been fully on the plan. But unfortunately, alone India doing is not going to solve the problem. We have already seen that the US has gone out of the Paris Agreement. All developed world came out from the Kyoto Protocol. So once they came out of Kyoto Protocol, they came and 15 that we will have another agreement, Paris Agreement, which also they are not following. I think another 5 years they will come with something else. So the issue is unless and until all countries do the mitigation, the problem is not going to get resolved. And I agree with you, we are going to face much more problems. But they were earlier thinking that they have a technology to address these issues and they won't have any impact. But the developing country like India and all, they will get affected, which they don't bother. But we have seen now, if you take only forest fire, in US and Australia, the kind of, or even in Europe, the people dying from a heat waves in Europe. In US also, the what we call as atmospheric rivers coming right from, I think, to Houston. Houston have a snowfall. So they are also getting affected. But they are still not ready to do, even the Trump has stopped all grants to any climate change related issues. Okay. And he says, drill, baby, drill. So there is a issue that unless and until all countries agree, or if the government is not, then the people has to say to or change the government which agree to that. So that is why the consciousness of people, is, at least in the democratic world, is very critical. And if you go to US, there are many state governments have implemented the climate related issue. But wherever the Democrats are there, wherever Republicans, they are not doing. So I think these are the issues which can be resolved only ultimately the people who vote for them. And I think today the climate change may not be an issue in any election or a democratic system, but as time passes and as we face more and more impacts, I think people also will realize that we need to ask political parties that what is your agenda for this? I think that is the only way we may be able to address. Otherwise, I think everybody will suffer. I think whether you do or whether you don't do, everybody will suffer.
So I just, nice, thank you very much. So I just want to know whether there is any policy or any thought process being sort of thought over regarding using hydrogen as fuel.
Yeah, hydrogen as a fuel is very much on the agenda, and the government has already announced the hydrogen mission. And I think they are waiting for some major breakthrough which can come. He mentioned about there are not many innovations. I agree. These are some of those things which has to come. And I understand that there is a major plan to use hydrogen as a fuel in all ships to begin with, because that is the much easier to do. So I think it will come, and we will have to use the different energy sources like hydrogen, nuclear, but I still feel that the use of fossil fuel will continue, even if we don't want. But we need to find a better ways to use them. Unfortunately, what has happened is that in 2015, it was felt that coal is not to be used. So all research on the coal has been stopped, like coal gasification and many such things. I think we need to have a better investment in how best we can use the fossil fuels. Because whatever you may do, you will continue to use fossil fuel for coming. So it is better that we find ways and means to use them much better than the way we are using today.
Thanks for a very nice thought-provoking talk. So I had a question related to some, there was a data which suggested that the forest area is less in India. So are there any science interventions in making policies of cutting down forests, for example, making highways in regions in the north, specifically close to Himalayas and things like that? So are there any policies or in place, or for rather than lowering down the forest area, because this is also one of the reasons we are having the climate change.
Yeah, I mean, the forest is being used for certain reasons, for certain timber, for paper and all that. So there is part of the forest which is definitely cut and used. But overall, the forest of tree cover in India has increased. We should have, as I told you, we have now 2.2 billion uh, hectares is already done. Uh, Compared to our goal is about 3 billion. So we are on that line. And as far as there are two issues which is coming up. One is the typical forest, what we call as a, people say it has to be a natural forest, which has of course better carbon sequestration and all that. So the other tree cover where the plantations, crops and others are also included, does sequester carbon dioxide. There is no issue, but they are not as good as a natural forest. So some people say that there is don't put these two together, because now what we are saying is forest plus tree cover. That is what the information is giving. So certain ecologists are not very comfortable with this putting them together. They say it should be two separate categories, because the actual forest in many areas have decreased, which is not coming out because of the more plantations which is being done. But I think as far as uh, carbon dioxide sequestration is concerned, I think if they put together, there is no harm, because all over world this is being done, and now they are also counting the cropland, because when they say greening of the world, which they are putting the crops also as a part of it. And in India, the greening is much more because of the increase in the crop area, because the irrigation is increased, especially in Rajasthan. The large area has now irrigated. So there is more greener India now than what it used to be 20 years back. So major change in India is also cropland, so which is also important, because that also uses carbon dioxide.
Yeah, thank you for a very enlightening talk. So I had a question that you mentioned this carbon dioxide levels increasing is causing this temperature to change. So since these are all differential equations, is there a sort of delay that you see this anthropogenic effect of CO2 level versus when the temperature started increasing?
Yeah. It is not immediate. I fully agree. There would be some lag, but I don't think we would be exactly will be in a position to say what would be the lag. But in certain cases, there won't be a lag, like the crop. We have seen like millet and all, their yield has increased. So it is immediate kind of a thing. And in sometimes, in some of the region, when the wheat and all the yield has gone down in particular region where the temperature shot up in March. But they are not overall, I mean, generalized, because overall our still wheat and rice production is still very high. I mean, it is increasing year by year. It is not decreasing. So it is not actually seen, but I don't think we could really model um, on a regional scale what likely to be impact. Because though we say that the carbon dioxide average value is at 423, it is not 423 everywhere. Okay. And those changes which are in a particular place, the carbon dioxide and their impact, I think we are not able to come to that level of modeling. That's why I said that we need climate models which can give at regional and local levels, which we can give a forecast. Then if we can do that, then what you say that we would be able to know whether what kind of a time lag would be there. Otherwise, right now we are just talking about average and the global level. In some cases, regional level, but not at the local level.
So, you also mentioned this is something I have also heard before, that when you increase the temperature and humidity base level, you are having more extreme events or the variability is increasing. Is there a easy way to understand this? Like the tropics have, for example, more variability than.
Yeah, tropics has definitely more variability and more, the uh, warming also in the tropics because the sun direct rays is coming. It is warming is much more higher. But if you really see the actual increase temperature, which is average, we may say 1 degree or C. But what we have seen that the increase in the average temperature in say Arctic or Antarctic or Himalaya is much higher. In some cases, 2 degrees, 3 degrees. So the average temperature is not necessarily a good indicator of what is likely happening. We have seen that in different regions, the effect is quite different. Though when you add up everything, the average may become 1 degree. But so this problem of differential temperature at different places, different humidity condition or different monsoon rainfall condition, how it translates into a local climate is not very clear. Like even in Bangalore, you must have experienced this season, June, July. Normally, June, July is warm. I mean, this year, the June, July was very cold. Morning it is 18, 19 degrees, like winter in Bangalore. Now, I asked many climate scientists, but they are not really able to model this and say this is the reason. So many local level, there are many things are happening which we have no idea. And that is I think the challenge which we have, that we need to model at that level because then only any appropriate action can be taken. So that's very important thing. But today we don't have an answer to your question. Yeah.
Thanks, sir. Thank you for a very nice talk. So my question or concern is related to two major issues. One is the waste management, which is a problem in India, as we know, especially mainly in developed cities. Another is we are talking about clean energy, right? And we are moving to the electric cars and going to use batteries, lithium-ion batteries. Now we have Tesla centers in India, one center in India. So we are going to the electric cars, going to use lithium-ion batteries. Getting these ions itself is very difficult. But are there thoughts, national level thoughts on how we are going to dispose these used batteries?
Yeah.
That's a big problem. Or are there clear and transparent information from countries like US who are already doing it?
Well,
It
there
can be a
is
problem.
there is some people definitely not only the batteries, even solar panels. You know, many square kilometers after say 10, 15 years, what you are going to do? There is no, I mean, people know that this is going to be a problem, but I don't think there is any effort to address this issue. There are some people who are trying to develop that from the batteries, whether we can retrieve the material back. Because if you can do that, then your requirement of those critical minerals will become almost 20, 30% only. So there are efforts going on recycling those batteries. But there is still not a success which you can say translate into a manufacturing level. You can do it in lab, but we need a process which you can do uh, many more and also build a method by which you collect all those things properly. Even our waste management, as you rightly said, is not appropriate. Most of the time, even plastic or all those things are some case it is being done, but most of the place it is not done. We don't segregate that dry, wet, and all those things, electronics. So those are issues, but I think that is where the awareness is very critical. Unless people themselves are understand and insist that this should be done separately. Then the recycling also becomes easy. If you put everything together, then recycling also becomes practical again. I mean, Bangalore has a good example. They started plastic, and some of the roads in airport are made by those recycled plastic. So, if you do, there is a way and means. But I think we need a system where not few people, but everybody does. And asking somebody else to segregate is not a good idea. Each household, if they segregate and keep it, I think that's the best. But that I think will take some time for really to materialize.
Yeah, so I have a question on the early warning system. So are we scanty on data, or are we deprived of models? What is, because the systems like the landslides and the glacier melt. So those things we do have enough data, right? So where are we lacking?
Yeah, the problem is like if you see a cyclone, we have been able to provide information even 7 days before, because all the observations over an ocean when it originates right from there, you can monitor till it comes both from the radars and the satellites. Now, if you see the other hazards like landslides, the problem is it is much smaller in size compared to what cyclone is. Though,
See developing.
yeah,
Sudden.
yeah. So let's say Western Ghats area is prone to landslide. Now, the most of the landslide occurs in this region is because of the rainfall. That means we should be able to monitor the either rainfall, which is available, but how the soil moisture is there. Because whether what would be the weight of that particular area where it can has to slide. That information on soil moisture is not available, nor there is any way really to measure, except you can have some wireless sensors if you can put it, and then you get the information about the soil moisture, which you can put it into models to give a forecast. Even if you do all this, the local topography and all is also equally important. What is the slope, or what is the different rock types? So the variables are many. It's not only one. So put this all together, people are saying that we would have an early warning system, but till today it has not happened. Only because we don't have that observation system. Unless you have observation, you can't model anything. So that is the fundamental issue. And what my thinking is that instead of worrying the developing, we should have simulations that, because today information about rainfall is available, right?
It will tell you what parameters you need.
Yeah, so you simulate for particular region that these are the different types of rainfall, which is the threshold beyond which it happens, then landslide will occur. That threshold would be different for different regions, and that simulations if we do, I think we would be much better off than developing early warning system.
I have a question on the climate models. I'm just wondering if, because of the global warming, overall, different components of the Earth system have become more coupled than before. For example, if you want to predict Indian monsoon, you have to model much more very distant systems than previously needed. Is that correct?
Yeah. Actually, now with the changes, the predictions have also become a little bit more complex. Because like if you say the monsoon, it's a global system. So what happens in Arctic or Antarctic or in Pacific or in Atlantic all affects the monsoon at different levels. So those changes also will get affected into this. We have been able to give a pretty good forecast of a monsoon now. At least on a short term is quite okay. Seasonal is also quite okay, but the extended and all that, there are issues still. But now last few years, we have seen uh, that the skill has slightly gone down than what we could achieve a few years back. So now the probable reason is we think that we need to increase our observations and both the satellite and the ground level. So the new Mawsum mission has been launched where these observations will be increased. The entire country will be covered by radars and many more other observations. So this is one thing which is being done. But the most important information which is required in our which was convecting system is information about the wind profile actually. And that is not available. They put a radio sonde, so you have some 1,000, 1,500 points where you have this wind profile, but it's not enough. So we have been saying that we need satellite-based wind profiler. France did launch wind profiler, and it was found that data is extremely useful for us to improve our monsoon, right from onset of monsoon to the very point. But there is very large amount of power requirement, and the France and in those countries it doesn't matter whether they have a wind or not because their system is quite different. So they have closed that, but I think India need to develop that wind profiler, or at least collaborate with France and launch on our satellite.
Yeah, in that regard, I might say that recently the IMD department has launched this new monsoon program. So as part of it, we have given some space in our Kodaikanal observatory
Okay.
to set up the IMD new weather balloon launches.
Okay. Acha, radio sonde.
Yeah.
Okay. Good, good. Mm.
Thank you.
Are there any questions online?
There's one hand up.
Yeah, you can,
Without question, you can mute.
you can unmute and ask the question.
Not a
You can type the question if you want. Yeah, okay, so if there are no more questions, let's thank Dr. Nayak. And I invite Professor Annapurni to present the memento to the speaker.
Oh, very nice. Yeah. Thank you very much. It's nice, real heritage meeting. So.
So we conclude the program. I thank each and every one of you for attending this seminar, this lecture online as well as online, and asking the questions and making the discussions very lively. I also thank the people behind the scene, the office staff from director's office, administrative staff, housekeeping, Yogesh and outreach team for all the arrangements, and also my colleagues in the colloquium committee for making everything possible. Yeah, thank you all.
There's a lot of interesting topics.
Yeah. Not sure whether really convey everything.